Okay, so the things, the guys who have been in the class are going to recognize this format. This is basically the same format I've used for the whole class. What we're going to talk about today, I just want to do a quick review of where we've been in the class, because although this is a short class, we actually cover quite a lot of material. And I want to make sure you have this in your head as to what we've covered and what you can use going forward. And then I want to talk for a few minutes about where AI in games is going, which might be of interest to some of the rest of you. And then we'll have the really good stuff, which is the games these guys have been working on. Again, for those of you who haven't been in the class, the way this works is it's a short 5-week class that builds up to a project at the end. Everyone who is in the class does a project and presents about their project, whether it works or not. And frankly, it is as important to get up if it doesn't work as it is if it does work. It's great, of course, to show something that does work, but it's important to get up and talk about stuff that doesn't. So we've done a lot of, we've covered a lot of AI in games, as I said, starting with the very definition. There's 2 definitions I gave at the beginning of the class. One is that AI is about the ability to act intelligently under changing conditions. You want opponents or helpers in the game to be able to work with you and work with the environment in a way that seems pretty smart. The other definition I like is that AI is all about making computers act like they do in the movies. You know, the closer we can get to that, the better off we're doing. We talked about different types of AI, strategic, tactical, and agent-based, and mainly we focused on agent-based AI in this, although with some journeys out into tactical AI. For those of you, again, who haven't been in the class yet, this is sort of a preview of what we cover. If you don't know or aren't terribly familiar with recursion and emergence, and I should have had event-driven programming in here as well, those are critical things you need to have. You need to understand these things, and we talk about them at the beginning of the class a bit, but they're just very important concepts to understand. Then we talked about the sense, decide, act loop, which is what an AI does all the time. They sense what's around them, decide what to do next, and then act on it. Did a lot of work on search, and especially A star, and that's theta star, which, who brought that up in class, theta star? Andreas? Yes, very good. Theta star is a really nice optimization of A star. Again, if you're not familiar with A star and you want to do anything in computer games at all, understand A star. It's the main screwdriver in your toolkit. Talked a bit about forward chaining and backward chaining. And then we went into some of the really good stuff, finite state machines, which lead us to behavior trees and hierarchical task networks, which are really kind of where things are right now in terms of what people are doing in AI. A bit about world representation and knowledge representation. One of the things that surprises some people is that you can't really do AI at all, or certainly not AI for games, without understanding how the AI understands the world. It was actually kind of a letdown for me initially when I figured out, oh, all the AIs see of the world are like these points on a grid. If you're doing way back when I was doing a waypoint-driven navigation system. And I somehow thought that the AIs saw this nice little cartoon world inside the computer, inside the game world. I was really kind of bummed out to find out that all I knew was like, oh, there's an XY point over here, an XY point over here, and one over here. But they have to understand something about the world. And it turns out that the more they understand, the heavier it is, the harder your work is, but the more kinds of cool things they can do. And then we went into knowledge representation, specifically both what are called symbolic systems, which I'll touch on just a little bit here today, specifically looking at semantic nets and frames and brushing by rule-based systems. I don't expect anyone in this room is ever going to implement an expert system. I hope no one ever has to do an expert system, but they're important to understand. They're important to understand because you can take a little bit of a rule-based system and put it into a frame, which then goes into part of a behavior tree, for example. And then we brushed quickly past the sub-symbolic systems. Neural networks and self-organizing maps on their own could be a whole class. Again, I wanted people in the class to have a concept, understanding the concept. So if someone says, we're going to use a neural network, you can say, well, hang on a minute. How are we going to do this, and why are we going to do it? At least you've heard of it. So things we didn't cover, or generally what's left. Learning, which we'll talk about a little bit today. Again, it's often not something you want to use in games, but it's something you need to understand. There's some real advanced topics that we'll talk about. And then the last thing, I felt like I had to put this up here, there's just no way around it. You can't just absorb this information and say, great, now I know game AI. Like anything else, especially with games, you have to do it. You have to work at it. You have to try it out. You have to write your own A star and watch it fail in really strange ways. You have to write your own flocking algorithm and try and figure out why the birds all fly to the edge of the screen and stay there, which is what happened to me on my first one. They literally went to the edge of the screen and stayed there because I had a minus sign where I shouldn't have had one. But that only took me 6 or 8 hours to figure out. Okay, so I want to talk a little bit about learning, and this is, if you haven't had a lot of exposure to AI, this may be fine, or it may be a little bit confusing. Don't worry about it. We're going to go past this quickly. I just wanted to hit this a little bit. I think actually this is where we left off in our last class. Just in terms of a high level, a way to think at a high level about learning in AI in general, and specifically within game AI, you want to take your current state, where you are, you have some behavior at time t, and then you try out different behaviors. I have B1A and B1B here, and then you have to have some measure of fitness. You have to have some scale in which to say this one is better than that one. The creature died, the monster died, I didn't die, that's better than me dying. Or, I got $10,000 here and I got $1,000 here, the $10,000 is better. So you have some fitness measure. And then what you want to do is say, well, great, in the future, I want to do this one, not that one, because this one is more fit. This one leads me to more fitness. And there's a lot of different ways to do this. They typically involve having some sort of higher probability. And I'll talk about this in implementation terms in just a moment. I don't remember, did we cover Monte Carlo tree search? I think I mentioned it at one point. If you're interested, there's a thing called, MCTI, Monte Carlo, MCTS, Monte Carlo tree search. This is not something that's required for anybody, but if you're interested in this, it's something to look at. Basically, it's a way of doing a minimax search, for those in the class who understand what that is, and then to project forward. And it's a way of doing a bunch of game iterations. Sorry, I should say this first. A Monte Carlo search is like Monte Carlo, like when you gamble. It's like trying to get a whole bunch of different options to find the best one. So what this is saying is you build up a tree, a weighted tree of options where you're playing games forward in time to see what the best option is. And it turns out this is really powerful. They've tried making, for example, you can make AI chess players out of just a regular minimax tree algorithm, but you can't make a good Go player. But you can make a good Go player if you use a Monte Carlo search. But part of what it does is really the heart of it is it does this. It says, oh, this one's a lot better. I won the game here. This one's a lot worse. I lost the game here. I'm going to reduce the probability of doing that in the future, and I'm going to increase the probability of doing that one. So this is, again, that's a fairly high-level description, but this is common to any kind of learning, really not just in games, but any kind of learning anywhere. Even if you look at things like evolution or operant conditioning in psychology, it's you want to do that, not this. And doing that, not this, just seems to be a mechanism that we see in nature and certainly in games. This breaks down, by the way, I just want to mention this, into two regimes is often the word used. Supervised learning, where you say, you start here and you want to get to there. If you get to there, you know you got the right answer because we understand what the right answer is. If you guys remember in our discussion of neural networks, how the back propagation goes up, it finds, oh, did I get the right answer? If I did, then reinforce that going back through the network by adjusting those probabilities up. So that's an example of supervised learning. Unsupervised is where you say, I've got a ton of data. I don't know what it looks like. I don't know what the data is. And the self-organizing maps we talked about allow you to cluster the data. So you say, oh, look, there's a nice cluster of data right here, another cluster over here. What does that mean? We don't know yet, but this way of learning helps you understand where the clusters of data are. And it turns out in our own lives, that's how we start to form associations between things, where we say, there's a cluster of data here. What does that cluster mean? I don't know. It means, look, if I look at it, it means every time I talk to a pretty girl, she talked to me back. That's pretty cool. Over here, it means every time I told a bad joke, the pretty girl didn't talk to me anymore. Okay, don't do that again. Do this one instead. So it's a form of unsupervised learning where you don't really understand at the beginning what the right answer is, but it allows you to form the right associations as you go forward. Actually, before we get to this, let me ask this question. I save this to the end, the learning part, because it's not something we do a lot in games. Why do you think there isn't a lot of AI learning in games? Yeah.
Because you want the enemies, especially, which are usually primary agents, to act predictably, and you want them to perform a role more than to act in a specific goal. Like if the AI was perfect in a shooter game and just shot the player with a headshot as soon as they turn the corner, that would be a very boring shooter game.
Okay, right. But even if it wasn't perfect, why is it important? You're right. You want the enemy behavior to be predictable. Why is it important that the enemy behavior is predictable? Why do players care about that?
Because the player's challenge is to overcome that predictability, and if it changes all the time, it's harder to be like randomized level. It would be.
Okay, you said a very important thing there. It would be like it was randomized. And the interesting thing is that even if you start off with where you're not very good at the game and the AI isn't very good, and you get better about the same rate, either the player will have the reaction of it's unfair because it's like the AI is always yanking the ball away from me just as I get there, or it'll seem random, which is completely incorrect because it's not random. The AI is learning along with them. But sometimes, so what that means is sometimes the AI will win and sometimes they will win as the player is getting better. But the player will perceive that as, oh, the AI is behaving randomly. And actually, we did some work on this back on The Sims where we tried having, it was a very, very primitive form of learning versus just random behavior. And to the untrained eye, they looked identical, which I have to tell you is extremely frustrating. Because you put in this really nice learning. Okay, the one we used was really simple, but it was really nice, and it was making the Sims less stupid. And what it turned out was we could just make them random and it had the same result. So is there ever a time when you would want to use learning in a game? What do you think? Come on, there's a couple good examples I think you guys should know about. Well, maybe they're too old now. Fable, black and white. Yes? They use learning? Yes? No? What? Quake uses, well, Quake bots do learn, that's true. Yeah, so how do the Quake bots learn? Okay, think about that for a second. Anyone played Fable or Black and White? Okay, how was learning used in those games? Either of those? Yeah, and okay, how did you tell them what to do? Yeah, you either hit them or you pet them. Yeah, so it's very blunt instruments. Like it's either this is really good or really bad. Did that work well?
Sometimes they learn by themselves also. Like I can't eat trees, that makes me cute.
Right.
They look at the villages to learn how to use the storage and those things.
So I guess the thing I was going to get to there was that there are some games, not very many of them, where the gameplay itself is about the learning. The problem with a game like Black and White, where, if you guys who don't know it, you could choose to be sort of a good god or an evil god, and you had this massive creature, these little tiny villagers, and you had to train the creature, which knew nothing at all. And if you trained it by punishing it, it would become this evil, nasty-looking thing. If you trained it to be good, it would be like this angelic thing. And that was great, except it didn't always work. You'd have this angelic, wonderful creature that, for no reason you could think of, or no reason you could tell, would suddenly stomp and kill half your villagers. It's like, that's really not what I wanted you to do. I've spent all this time training you to be nice and kind, and then you go stomp half the villagers. Or the evil creature would run away, just suddenly run away. And this is why you don't see it more often, even in games like that where it could be used, is because it's very risky as a developer. It's like having an interactive play or something like that, or if I ask you guys to say, yes, I want you to ask questions, I have no idea what questions you're going to ask me. I could get some really weird questions if you were thinking along those lines. In a game where there's learning, you can never quite tell or never quite predict totally what the game is going to do. And that means that the player's going to have an inconsistent experience, some of which they'll perceive as random, and some of which they'll just perceive that you're a bad designer because you didn't give them a perfectly good experience. Now, having said all of that, I want to say this is changing. This is changing slowly, but probably in the next few years, you're going to see more games coming out with more interactive NPCs, which we'll talk about here, and more learning going on in them, because people have now been playing games long enough that they understand, oh, this isn't a book, this isn't a movie, this is really an interactive experience, which can change over time. As people who, of your generation and lots of different generations, sort of get comfortable with that, they'll say, oh, inconsistent is fine. I'll just restart and or I'll just move on to the next part of the game, and it's no longer a problem. Anyway, so that was a bit of diversion, but I did want to cover why learning isn't more often used. So let me just go through this quickly. In terms of putting learning in, what you want to do is find out where the thresholds are. If you have actions A, B, and C, and there's an 80% of the time B follows A, and then 90% of the time C follows B. But on either end of it, there's very low probability. You can say, you know what, these three things go together. And I can learn something about them. I can learn that they're correlated together. There's an interesting bug in the way we reason, which is that if we see things happening together, like A, then B, then C, we will, as humans, we will tend to assume that A causes B and B causes C. Now, that's not necessarily the case. Just because they happen to go together, they could just be correlated, not causative. But we tend to assume, well, A caused B and B caused C. And it turns out this is a really powerful part of learning. If you take away that assumption, it's much harder to learn anything. So that's why sort of bug or feature, the answer is kind of both. And if I've spent too much time on this already, but if anyone wants to talk more about this as we go on, we can. Just really quickly, I wanted to hit this in terms of how to implement this in the kinds of systems we've talked about. We talked about in rule-based systems how rules are either often used just straight down a list, or they're used randomly. And if you start to see, hey, every time I use rule 120, the next rule that I use is 150. Well, now you can start building up an association between those. So you say, just go ahead and check rule 150 first, because it might be the one you want to use. Same kinds of things in a behavior tree. If you have a sequencer, you can actually have auto-created sequencing of chained behaviors. Now, I should say this is a research area. It's one that I'm working in to create chained behaviors on the fly based on what the agent sees or experiences in the world. And then the same kind of thing with the semantic nets, where you can change the link values between two nodes to say this one is a much higher priority or higher probability than another one. And then finally, I don't even want to get into this because this right here in one sentence is a whole course. Doing like backpropagation training on a learning vector where time is one of the pieces of the vector is a huge deep area. It's like the quantum mechanics of AI. But it's a really cool area too. So if you're interested in that, we can talk more about that. Okay, some advanced topics. These are things that aren't necessary for game AI, but certainly ones you probably want to be thinking about. Conversational AI comes up a lot. Everyone thinks at one point or another, I know what I'm going to do. I'm going to make the perfect chatbot. I'm going to make a chatbot that really works. Turns out there are prizes for this. There's the Loebner Prize, which is given out every couple of years. Lots of entries go into this. And the idea is who can fool a human conversationalist the longest? Because no no chatbot can do it for very long, but they all try and do it for longer and longer. Oh, I should have skipped to the first bullet. Do you all know what the Turing test is? Yeah. Okay, Alan Turing was one of the fathers of computer science, and his idea was a very simple one, which was if you can't tell, when you're talking through a computer, if you can't tell the person you're talking with is a human or a computer, then we've achieved artificial intelligence. And it's a very operational definition. It gets back to the very sticky point that, frankly, you never know if somebody else is really intelligent or not. You guys all assume that I'm intelligent. You assume that I'm a real person, I'm not a bot. But you never know, right? I mean, the person you're talking with could really be a bot, could really be an AI. You're talking, and if you spend any time on Reddit, some people, in fact, seem like bots. But the idea is that if we make AI good enough, and especially natural language processing good enough, we'll get to the point where you really can't tell the difference, and that's sort of one of the big goals for a lot of AI. One of the big problems with this is creating utterances, creating things that the bots say or the AI says that aren't pre-assembled strings. Now, some pre-assembled strings are fine because we all say, hello, good morning, good night. We have these things we say that are canned, if you will, but for general conversation, you want the AI to be able to make up its own things that it says. And this is something, again, that I would love to say I'm working on this right now. This is something I'm trying to get to the point where I can work on, using hierarchical task networks for conversational structure. Think about it, again, for those of you who've been in the class, a task network that breaks down into multiple hierarchical tasks where each part of that is part of a conversational structure, the beginning, the middle, the end, and they can loop back on each other. So you can have multiple multiple middles within that beginning and end. I think that there's a good way to make conversational AI that uses this kind of structure so that the conversation seems really, really natural, as opposed to what we see now in a lot of chatterbots, which is they seem kind of schizophrenic. They'll jump from topic to topic to topic, and you're like, wait, that didn't make any sense at all. So to keep that from happening, I think using HTNs is something that's going to be pretty fruitful, but we'll see. And then another big part of it is adding emotional semantics. The idea that if you say, my dog died, that might be a very sad thing. My dog died, he was my friend for 15 years, et cetera, et cetera. Or my dog died, but that's okay because he was threatening my family, or he was a supervillain dog who was going to eat the world. I mean, I don't know. But there are different emotional semantics you can attach to any given sentence. And this is something that we don't currently see very much at all, in fact, in conversational AI, but I think is going to be really important. And that leads us to our next big topic, and this is one that a lot of my work has been in, which is emotions. These have been ignored by the AI community. Well, they were really steadfastly ignored for about 50 years. People just didn't want to deal with the messiness of the AI community, and I gotta say, I think we're all misled by Star Trek. Mr. Spock was completely logical, and he was intelligent and awesome, so therefore that's what intelligence was about. It turns out, in fact, that if you don't have emotions, and there are people who have various neurological conditions there's one guy in particular who is a very famous case, he can understand emotions, he can talk about emotions, he just doesn't have them. And he cannot, truly, literally, he cannot decide what to have for lunch. If he's not guided to his car, he can't figure out how to get into his car and turn it on. He can't do anything because he doesn't have access to his emotions. What emotions give us is a way of making really fast, kind of messy, but pretty good decisions. Not always the best decision, but think about it. What's better for lunch? The roast beef, the turkey, the ham, the soup. The soup, you added soup? Oh no, now I gotta go back and start thinking about it all over again. How many variables do I have to weigh? Well, I had roast beef 2 days ago, but I had soup yesterday. You can spend, and like this guy, E is what E I think is what they call him. Anyway, you can spend a long time, far too long, thinking about this. Whereas emotions just go, yeah, I feel like soup. Soup it is, done. And this is, when you have a ton of data, especially a ton of conflicting data, emotions give you a way of cutting through all that and not getting lost in the decision making. The problem is, of course, we have to have a way of describing emotions, which is where my research really is. And that's something that we don't know a lot about yet. Then there are some really big questions. And I've had, I gotta say, some really interesting arguments about this. Can AI have emotions? People say, oh, sure, they can mimic emotions. But can an AI really have emotions? And I would contend that yes, they can. Some early work we did involved an agent. I won't tell you the story now because I'm gonna take too long if I do, but we had some agents that had different personalities, and one of them was very lonely. He was always lonely. He didn't know how to interact socially with the other agents. And it felt to all of us looking at him like he was lonely. And you can say, well, he was just simulated loneliness. But you've seen somebody sitting on a bench, and you can say that person is lonely. Now, maybe they're just acting. Maybe they're just simulating loneliness. How do you know? At some point, we imbue other people with our own humanity. At some point we say, this person is lonely, this person is angry, those two people are in love. They're not faking it, they're in love. Now then we get into all kinds of things like, well, hold on a minute, it's a movie. Are they really in love? Maybe not. Is he really lonely? What was the movie? Eternal Sunshine of the Spotless Mind. Jim Carrey managed to bring across about 5 different kinds of loneliness just with his face. It was wonderful. Was he really lonely? I don't know. He's a strange guy. He might be. But anyway, sorry. The point of this is that there's a whole lot about emotions that we don't know, and that we tend to make assumptions that only we have emotions. And yet now there's really good neurological and behavioral data that says, yes, in fact, dogs have emotions. They don't have the same kinds of emotions we have, or not all of them, but they do have emotions. So then you have a question of, should AI have emotions? And if so, should they be like ours? A lot of the reason we have the emotions that we do is because of our biology, of how our blood pressure works and how our brains are organized. If you want an AI to have emotions, should they have the same kinds of emotions we have, or should they have some that are more relevant to the kinds of things they're doing? Like, I don't know, if my laptop was a robot, at some point it needs to get more electrical power. That would be like hunger, okay? But what other emotions should it have? Does it have a need to interact with me? Is it going to come up and bump me on the ankle and say, hey, you haven't typed on me in a while? I truly don't know. It's a really good question. And some people, I have to say, are some of the discussions I've had with people, they seem almost offended by the idea that we would impose our emotional set onto AI, onto robots in one case, or AI in games in another case. The one thing I can say is that if we have, in the case of game AI in particular, if you have NPCs you're interacting with, you want them to be able to understand and reflect back the emotions that the player or the players in a world are feeling. And to do that, they have to be able to operate with the same kind of emotional set that we do. So if every time the players in the game got angry, the AIs laughed, pretty soon players would all leave. They would get really angry and leave. That would just be an inappropriate response. But if the players got angry and the AIs got angry, then you say, oh, now I understand you. Now we understand each other. We're both angry about this. We're both afraid about the same thing. We're both happy about the same thing. So that's why you probably want to have AIs having the same kinds of emotions we do. But this is a huge open question. And there's a lot of different possibilities along these lines. So built on top of this, though, on top of emotional AI, is social and cultural AI. Getting AI to interact with other people socially is something that a lot of us are working on now. And this comes down to things like emotions. If you don't have emotions in AI, they don't know how to interact socially. They don't react to the same cues that we do. But then there's things like conventions. Meeting for lunch is a convention. And many years ago now, another AI researcher asked me, can 2 of your agents agree to meet for lunch tomorrow? This was probably, I'm trying to think what year this was. This was probably 10 years ago when I got asked this question. To this day, I can't answer that question. I mean, I could make 2 special purpose AIs that their only reason for existence was to get together for lunch. That's not really the point. The point is thinking about what goes into understanding what lunch is, what it means socially to meet for lunch. For example, meeting for lunch in a lot of cultures is a perfectly fine thing. Anybody can meet for lunch. If you meet for breakfast, that means one of 2 things. Either it's a more intimate meeting in any event, but it's like, we're going to meet for breakfast because we're going to get the day off started right, and you know, we're going to do these things, and that's great. Or we're going to meet for breakfast because we spent the night together the night before. And that's a very different thing. Or I want to meet for dinner, but I want, not only do I want to meet for dinner, I want to bring you home to my family, to meet my family for dinner. Now, that's a very different thing than just meeting for lunch. So you've got all these social conventions built into this. And then, you know, what if tomorrow is Christmas Day? We can meet for lunch on Christmas Day, really? For like a business meeting? That doesn't sound right. What if you're on a desert island? There's a whole lot of what ifs here that an AI has to understand about what it is that we consider to be a very simple social convention of meeting for lunch or going to class or whatever it is. These things that we take for granted because we've lived with them our whole lives are things that we have to give AIs the ability to understand. And that turns out to be a very, very difficult problem. So hopefully someone in this room will be able to make a lot of progress on this, and we'll all have AIs that can meet for lunch. I should say, by the way, that this is not just an academic problem. In fact, I just read this morning about Google is doing a lot of research into this, of course. That was a press release. I can't bring it to mind now. But the idea of having personal assistants. So Stephen and I want to get together in Skype, and his schedule's all crazy, and my schedule's kind of crazy. So we have our personal AI assistants that arrange a time for us. And all I know is that, 11 o'clock one day, I've got a Skype schedule for Stephen. I have no idea why. I don't care why it was scheduled for that time. But my AI agent has taken care of it. And the same thing for him. His AI agent has taken care of it for him. But to do that, they have to understand what our times are like. And they wouldn't want to, like, if my AI agent scheduled me for a meeting at 2 o'clock in the morning, it better be a very important meeting. Or else I'm going to fire the agent and get another one. But anyway, the point of this is that this kind of AI takes a lot of knowledge that we don't yet have. But in terms of trying to draw this back to games, it brings us to, it brings up a lot more things that we can do. If you can imagine a world, a virtual world with AI agents in it that understand what it means to be socially offended. Well, now you have Romeo and Juliet. If you can have agents that have emotions, they can be in love, they can be offended, they can fight each other, they can not like each other. Wow, now you've got Romeo and Juliet world, or something even better than that. Or you've got a world where you as a player stumble into a situation that was perfectly fine until you messed it up, and now you got 2 families that hate each other. Now your task is to get the families to not hate each other, not go to war with each other. Well, to be able to do that kind of thing, which is far less mechanical and much more organic than we have today, you have to be able to do this kind of thing. Finally, the last point in here, there was a, I think Danish researcher, Hofstede, who came up with 5 dimensions to describe culture. It's kind of an interesting model. And there are things like masculinity, how much gender separation is there, how much power separation is there in the culture, how much long-term planning does the culture do. And if I think about it for a couple minutes, I can get the other two dimensions. It works pretty well as a way to describe sort of package up cultures. It's honestly a really insufficient model, but it's one a lot of people use because it's 5 things, and you can usually remember 5 things, unless you're trying to do it off the top of your head in a lecture. But it's a way of, what this allows us to do is to create AIs that match cultures. So you can say, like you guys played Civilization. They do a very, very simple model, cultural model, to say this culture is aggressive versus passive or fearful. This one's territorial. This one's not. And you can create models like this to create what feels like a different culture. So if you're going to deal with the Babylonians, you got to be careful because they're territorial. They're aggressive. Now, by the way, going back to the emotional discussion, this would be a good example of different emotions for the AI, where yes, you might want to say, if you violate their territory, they're going to feel offended or angered, but really there's sort of a territoriality emotion that's happening there. And that might be a good example for having a specific subset of emotions for AI than you'd have for people. So here we get into the really deep water. Theory of mind is something, it's the idea of me knowing that you have a mind in your head, or wherever, but that you have a mind, and me reacting and interacting with you on that basis, that you're not an automaton, that you're not just a passive thing, that you are a person. And if I model myself, if I have a theory of mind about myself, that is me having self-awareness. And this becomes a very strange thing. Again, some of the agent modeling we did several years ago, all of our agents had opinions about other things in the environment, including themselves. And Stan, the one I mentioned before, who was always lonely, had a terrible opinion of himself. So you could say in a limited way that he was self-aware in a very limited fashion and really didn't like himself. And that's a terrible thing. So one of the things with self-awareness is that we're cracking open, if we make AIs that are in any way self-aware, we're sort of cracking up a whole new thing where the AIs can not like themselves, be angry with themselves. And then it gets into things like, if I have a model of you in my head, and I want to know what you think of me, you can get sort of down this rabbit hole of what I think, you think, I think. So it's like, we're going to go see a movie, and there's a particular action movie I want to see, but I don't want to tell you that. I want to see what you think I want to see. So what do I think you think that I think I want to see? And you can go back and forth in this. And it turns out that behaviorally, humans don't go more than about 3 levels deep. So I can think of what you think, I think, you think. But you see, even there, I have trouble. And if you sort of get any deeper or any broader with more people than that, it gets crazy. What this leads us to, though, is empathy. Several things. The first of which is empathy, which is the idea that you have a mind, and I know that you have a mind, and you have emotions, and I have a relationship with you. If I have those things, then I can have empathy for you, meaning that I can feel positively disposed to you when you are having a bad time, because I know you're not just a broken toaster. You're a person who's having a bad time. But this is insanely difficult to do. We started off with a fairly simple model of empathy that we threw away because it was just like completely inadequate, and it's again, very difficult thing. No one's really done it yet. Humor, there are a couple of joke-telling chatbots. I don't know if any of you have seen them. Most of their jokes are canned, they're pre-made. The ones I've seen, there's one I saw several years ago that was trying to make jokes on its own, and it was really weird. I mean, it was I don't know how to describe it. It was like a joke-telling drunk space alien. It would say these things like, "Isn't that funny?" You're like, "No, I can't even." And it was so offbeat, I can't even reproduce it. It wasn't even like avant-garde. It was just like, no, you got like a bad association algorithm going there. It was strange. The thing is that humor for us happens actually at 3 levels. It happens neurologically. Some things we think are funny is because 2 neurons light up in different parts of our brain that don't normally light up together. And everybody goes, "Huh, that's unusual," and we interpret it as being funny. Linguistically, there are some things, there's a lot of jokes, puns, and things like that that happen in one language, not in another language. For those of you all speak Swedish and English, you probably know jokes that work in one and not the other. And there's some things that are just cultural. Oh gosh. There was a great example of See, now I can't even tell it. I've completely ruined the joke. In the US, you can't tell jokes about a guy having affection for his mother, whereas in Japan you can, because there's very different norms there. A guy having affection for his mother in Japan is, saying like wanting to live with his mother. That's a perfectly fine thing. Whereas in the States, it's kind of a weird thing. So there's cultural parts of this that aren't even linguistic or neurological. What happens when you get like a really big joke, and analyzing humor, by the way, is one sure way to kill humor. But when you can hit all three of these things together, that's when you get a really good joke. No one, as far as I know, has done any kind of really good humor AI. And the last one, and this is one that a lot of governments are very interested in for reasons that might be obvious, is deceit. I mentioned about the self-awareness, what's my model of how you think. If I want to deceive you, if I want to say, this car, you should totally buy this car because this is a great car. No, its wheels haven't fallen off. Well, maybe yesterday they did. But if I want to deceive you for my own ends, I have to have some understanding of what you're thinking and what your goals are. I have to have a theory of mind about you and then tell you what I think you want to hear. And this is, so I also have we haven't even talked about values, but I have to have some idea of what your values are. So this is a great car. It's a bright red sports car. It's going to get you lots of girls. That's one value. And it's not going to cost you very much. That's the second value. Or this is a great car. It's gray and it's very reliable. So you don't like flashy things and you want something that's not going to fall apart on you the next day. Two very different sets of values. I may be deceiving you about both of those, by the way. Yeah, question here.
Don't you have to actually, usually sellers know the person they're selling to. Like they would know as soon as they open the door.
They're very good. The best salespeople are ones who can read people very well. So you go in, you're dressed a certain way, you hold yourself a certain way. Did you bring somebody else with you, a parent or a spouse or something like that? They read all those things. They say, you're going to buy a flashy sports car. This other guy over here, he's going to buy the gray car that is never going to break on him. And it gets really hard. In San Francisco, for example, in the San Francisco area, how you dress is not at all a signal of who you are, how much money you have. And it drives salespeople crazy. Because they'll get a guy who comes in a ratty t-shirt and jeans and says, well, yes, I'd love to buy this Tesla car for $100,000. Here's my cash. And they just have no way of reading people. Whereas on like on the East Coast in the US, someone like that would be dressed in a very nice suit because that's a signifier of their wealth. So yes, you have to have some idea of who you're selling to or who you're trying to deceive. And so think about this in game terms. Why would you want to deceive someone? You want to sell someone a really bad spaceship, or you want to trick them out of something. So you have to have some idea. If you're doing this with an AI, you would have to have some idea as a player of what that AI wants. Or from the opposite point of view, the AI would have to have some idea of what it is you want and try and basically trick you that way. Yeah?
Also the means of communication. I mean, people communicate with body language so much.
Yes.
And facial and
Yes.
tone of voice.
Yes.
That's also a big difficulty here with AI.
It is. And I think that's...
Mimicking face and all that.
Yeah, that's... Sorry, just go forward a little bit. This is an excellent point. The whole problem with natural language and the fact that we don't have really good high fidelity facial expressions or posture, body language, all those things become really difficult. If it's just lines on a screen, it becomes just insanely difficult to figure out what it is that the AI is trying to get across, or much less for them to read what you get across. There have been a couple projects that have tried using Kinects, by the way, the Kinect device on the Xbox, to try and read people's facial expressions or try and read their posture. It turns out it's really difficult because when we're playing a game, we often don't have the same corresponding posture or facial expression that you would expect from what we may be feeling inside, especially if it's an exciting part of the game. I may not be jumping up and down. I may be hunched over my computer, which doesn't really say, I'm really excited. So yeah, it's really a hard thing for them to read. Was there another hand in the back? No? Okay. Let me go back for just a second. I want to, again, hit some of these things in terms of some of the trends that are happening. Pardon me. Multi-agent simulations have been kind of on the outs for a while, but they're really coming back now. I don't know if you guys have seen Prison Architect or Versu is a little bit different. It's a smaller group, but this is more of a society of chatbots. There's a couple of these. Versu is one, and another one that are simulating Jane Austen dinner parties. I'm not sure why Jane Austen dinner parties are suddenly the hot thing. but they are kind of, well, there's a lot of interplay and a lot of different levels of interaction there. The great thing about these is they can give you some really deeper experiences, and they are moving beyond the old roller coaster tycoon to things like Prison Architect, which gives you a little more sort of meat in terms of the AI to deal with. And these are a move toward real social AI, which is something that a lot of us have been pushing for a long time. The idea behind this is that the social behaviors, like in a Jane Austen dinner party, you're not going to shoot anyone, hopefully, but the social interactions become just as important or even more important as the sort of more common ones where you're shooting at something. A lot of these, by the way, in terms of techniques, use a mixture of behavior trees and task networks combined with frames. So frames, in this case, give you is what's appropriate versus inappropriate behavior. Does it fit into a certain frame or not, along with dialogue. And then helper AI and NPCs are becoming a lot more common. Two big examples: the Call of Duty squad members have become very good for the limited interactions that they do. And then bots in MOBAs started off being really, really simple, and they've gotten a little more complex over the past couple of years. There's a game coming out from Kixeye called Tome that's in beta right now that has, I've only seen a little bit of the bot behavior, but what I'm told is the bots have some really nice advanced behaviors as you go on in the game. The bots become smarter as well. And then I hesitate to put this up because it's not quite true, but bots that have relationships to you or to each other. Banished, by the way, is a game that's coming out. No, came out Friday?
Yeah.
Anyone have it? Tomorrow. No, okay, I thought it came out last week.
No, I'm buying.
Okay. Okay, so it's not quite out yet. I've been following it, and I want to get it because I already have a dozen games I should be playing, but this one looks interesting. This is this sort of a SimCity mixed with Age of Empires, kind of. Looks really interesting, but the bots have relationships, the AIs have relationships with each other. I think still pretty primitive, but it's moving that direction. What we haven't seen yet, and what's something I'm trying to do or looking for, this idea of personal NPCs, where you go into a game, you've got buddies or sidekicks or family members that inform you, the player, about the game through their own relationships with you. And they are like, this is like, in Sid Meier's Pirates, he does this thing where you have to rescue your family members. You rescue your sister, you rescue your aunt, you rescue your uncle, but they don't do anything other than give you a piece of an Incan treasure map. But if they could do stuff like say, oh, now that you've rescued me, I can help you with this evil governor over here, now you're starting to get into some really interesting AI gameplay. Okay, mentioned some of the issues. I mentioned the UI UX issue already. Just for what it's worth, I want to hit the second point here. Natural language is hard for anybody. It's hard for all of us. We all have a hard time speaking well. We have a hard time listening. If you add an AI into the mix, it just gets worse. And in terms of the cumbersomeness of it, imagine playing a game like Monopoly, where you aren't really playing the game, but you're sitting beside someone, and that person is playing the game, and they have to tell you about everything that's happening in the game, and that's the only way you have to interact with the game itself. So you can't move on to something. They have to tell you every time, oh, so-and-so just landed on this square, and do you want to build a house, or do you want to build 3 houses, or do you want to move on to this other square? What do you want to do? If you have to go through an intermediary like that, that's a lot of what like playing a game through natural language is like. It's really hard and cumbersome, and that's one reason why I don't think that it's happened. Why people haven't actually made it happen yet. And then the last part on this one is just in terms of middleware. You may have heard there have been a few middleware companies sold recently, and some are getting some more notoriety. It's happening slowly. This is something I thought was going to happen 5 or 10 years ago. Slowly, AI middleware companies are making progress, but it's the point now where they can all do A-star pathfinding on a nav mesh pretty well, but they can't do dialogue. They can't do behavior. Some of you can't even do behavior trees very well. So it's slowly happening. Without this, though, what happens is that first of all, it's hard for the middleware to make general solutions, and without that, everyone has to re-roll and recreate their own solutions every single time, and that just slows everything down. So that's one of the major issues in AI. Okay, last couple minutes we got here. What's next? There's a lot of work that's been going on since 1960 or so. So it's been slow making progress on creating stories with AI. Using AI to do story direction. There's been some recent work done using, and I think I mentioned this earlier in the lecture, using behavior trees as sort of the story structure itself. So rather than thinking about behavior trees, again, sorry for folks who aren't really aware what those are yet, but if you think about taking behavior trees and rather than applying them to one agent, applying them to a whole game and the game story, what this allows you to do is to create, for the player to create their own path through the story world without you having to create this huge branching narrative, but where the world in effect reacts to the player as if the world has its own behaviors. But the world's behaviors in this case are what the individual agents or bots in the world do. So this is a way for the game to say, okay, based on the player's choices, I see they're trying to make this a really aggressive game. Great, we'll hit them back aggressively. Oh no, look, now they're turning this into more of a love story. Okay, we can do that too. We can take this one AI that they were fighting against, and suddenly now this is their love interest. So there's by using the behavior trees and the task networks, you can modularize these aspects of the game of what the player may do to create an actual story of the game. Now this is what's next. This hasn't happened yet. People are trying it now. Utility systems are coming back again. They were first seen in the Sims, where this idea of the action is chosen based on goal satisfaction, which is sort of the utilitarian basis for it. In The Sims, by the way, this was done very poorly. The result was great, it worked well, but remember how I said before how randomization turned out to work as well as anything else? The way The Sims has worked for a long time is they do all this calculation to create a small list of actions the Sim might take next, and they choose randomly one of those actions. When I was working on the Sims 2, this drove me nuts because, among other things, it meant we couldn't predict what the Sims were going to do, and it also meant they would do very strange things, like, I'm standing talking to you, I will talk to you for a while, and now I'll brush my teeth. Why? Because that came up as a random choice. It makes no sense at all, but that was kind of one of the problems of The Sims. However, with some of the more advanced things we have now, like the task networks and the behavior trees, you can constrain what they do from a utility point of view to say they aren't going to go choose to brush their teeth. They might choose to end one conversation and start up another conversation over here. So you can constrain their behavior a little bit more, and this is why this is coming back. And then finally, the last sort of overall point is that AI is really maturing. It's been treated a lot as sort of this, for a long time, as this separate thing from the gameplay. Like 3D engines were treated this way for a long time. For a long time, it was like, we don't care what the gameplay is. We just want the game to look really cool. I remember seeing and drooling over Unreal demos where you could shoot missiles through a smoke stream coming up from a grate, and you could see the little swirls in the mist as the missile went through, and it was really awesome. What did it mean for the gameplay? Absolutely nothing. But it looked really cool. AI has been kind of the same way for a long time, whereas this AI does these really cool decision-making things, and like in The Sims, it chooses from a random list at the end, so it doesn't really mean anything. Slowly, we're starting to see the AI world mature, and to see the AI actually say, okay, we want to use this because it's going to make the game better. Yeah?
Yeah, I was just wanted to have an anecdote about that. I remember Fear being touted as
Yes.
a great AI example of them organizing and flanking and stuff, and I remember not being very impressed when I played it the first time. And then I sat down my brother, who isn't as good at games, and I noticed that when they were alive longer, they could do really amazing things. But as soon as I saw them, I just pointed my crosshair and shot him in 3 seconds. I didn't have time to do anything fancy. Take cover.
That's a good story. I actually had a similar experience in one of the Call of Duty games where I tossed a grenade down a hallway and managed to bank it off the hallway. So it was great because I didn't get these soldiers who were down here, and peeked out to see what happened. So I peeked around this door and saw a soldier throw himself on the enemy, soldier, the bot, throw himself on the grenade, which was amazing AI behavior. It was terrific to see. It turned out later it was completely canned script. I was really bummed. But if there's a grenade here, one of these guys will leap on it. That was it. But in terms of something like Fear, which has really good AI in it, that's a good example of AI serving the game. Another one, by the way, is EverQuest Next. I don't know if you guys have heard of this or tracking it all. The game overall is a voxel-based destructible world MMO with apparently fantastic AI and chocolate sauce. I mean, it really sounds like it has everything. I know some of the guys who were working on the AI for this, and they're doing some very, very interesting work. They're also trying to be very careful to make sure that, like it says here, that the AI serves the game and not vice versa. They're not just putting in AI just to put in AI. Well, okay. Knowing anyone in that situation, they'll probably do a little bit of that because it'd be hard not to, because you just want to put in cool AI. But really, they're trying to make it so that it serves the game. I haven't looked forward to an MMO in years, and I gotta say I'm looking forward to EverQuest Next. It looks pretty cool. Yeah.
I have a question on social AI.
Yeah.
The game LA Noir. You know about it?
Yeah.
Do you know what they use?
The AI on that was actually fairly rudimentary. It wasn't really complex. They spent a lot of the time on the facial expressions for that one. But I believe the game was really pretty linear. It gave the illusion there was a lot of choices there, but there wasn't really a lot going on there. Yeah.
If it was all scripted or
Oh, yeah.
they actually made calculations. And
No. It was they spent millions of dollars on the facial scanning and things like that, and said, oh yeah, we need some AI. I mean, really, I think it's been a while since I looked at this one, but I think it didn't even really use pathing. I think it used it didn't use like a nav mesh. I think it just used like node to node for how the characters walked.
Yeah.
So if you play the game again, you'll see them walk exactly the same place. Yeah, Jerry.
I was thinking on the director story generation. Left 4 Dead
Yes. Yeah.
has, the AI for the zombies, etc., isn't especially impressive, but the AI for actually doing the pacing of the game.
So
Called the director, so it actually mimics the hero's journey story arc of movies, where you have like a build up and then a peak and then you have a relaxed moment, and it bases the peak and encounter on what zombies to face and what things to spawn
yes.
for people to have those experiences.
Thank you. That's an excellent comment, and they did a really good job with exactly what you said, which is that they said, okay, we've been building up. We sent you 4 zombies, then 6 zombies. You did pretty well. Okay, now we're going to send you the boss because you're sort of ready for it. Not just ready for it in terms of your skill, but in terms of your own excitement and engagement with the game. My guilty admission about sorry, you said Left 4 Dead? I was thinking Last of Us. You said Last of Us?
No, Left 4 Dead.
I'm sorry, I was thinking Last of Us. Sorry. Yeah, Left 4 Dead. Let me think. Left 4 Dead they had some really interesting AI. Sorry, it's been a while since I've thought about this one, but they had some really interesting zombie AI in terms of how the zombies grouped. Did they also do the like the ascending difficulty?
Yeah, I mean, I was thinking about it because they actually called the AI. It's called
The director, yeah.
But it takes in a lot of things like spawn positions and also angle of where the groups of zombies would come from, depending on
The thing I remember that it reacted to what weapons you used. So depending on the weapons you used, yeah, that they would send stronger zombies against you. But I haven't looked at that one in a long time. I was thinking, of Last of Us, which I was going to say also this thing where they send different strengths of things against you. Has anyone here played Last of Us? Okay, has anyone watched the movie? There's like I think it's 7 or 14 hours on YouTube. It's terrific. I mean, I haven't watched the whole thing, but it's amazing. You have to fast forward through some parts of it just because like okay, I get it. It's really a bad time, but it's very linear. And a lot of people complained about the gameplay because the gameplay wasn't a lot there because the story was so good. It was like you can't deviate too much from the story. But as a result, if you just watch the movie, it makes a great movie. Now, what's interesting though is that a couple times in the movie, mostly what they do is they edited out all the parts where they died or things went wrong. But there's a couple times like there's one point where they're trying to jump a gap and they don't quite make it and they fall down but they don't die, so they climb up and jump it again. And it was those times I was reminded, oh right, this is a game. This is a game where most of the time you do that 5 or 10 times until you finally make it across the gap and you go on. But I got to watch it just as a movie, like anybody else can on YouTube. It was really interesting how well that worked as a movie and how well the rising tension worked, which I think was partly due to the kind of AI they were using as well as the whole world design and the character design. I have to say too, the AI for the girl, your daughter in the game was really quite good. It was very limited in what it could do, but for all that, it was really quite good as sort of the personal NPC I was talking about before, an example of that. I think that's all I have. Thank you all very much. Any last questions before we move on to the next and final phase here? No? All right, well, thank you all very much for coming. I hope this has been interesting for you. And if you haven't taken the AI programming class, I hope you will do so next year. Thanks very much. If I could have the guys who are going to present their projects come down here, if we come down close to the front, that would be terrific as well.
Yep.